The recording is started. Now, remember that we said that the computer, the numbering system in the computer is either 0 or 1, on or off, which is represented by a switch which is either turned on or off. Now, the component in the computer which does that operation is a transistor, which is either on or off. Now, somehow we have to be able to convert a number like 7 that I type on the keyboard to a number which is only composed of 0 and 1. So to understand that topic about binary numbers, I'm going to explain a little bit your decimal system that you're using right now since grade 1. So let me just change the screen. Okay, do you see this whiteboard?
Yes.
Excellent.
Yes.
Now, beautiful. Okay, when I give you a number like, let's say 12, oops, wrong color. Let's say the number 12, you can see it has 2 digits, 1 and 2. Now, this one, if I want to represent it in decimal, or the way that we already working with it every day in our life, I know that 2 is in the first position here, and 1 is in the second position. If I want to express this one in exponents of the base, remember in decimal numbers, like this one, your base is 10, meaning that in this space I can represent numbers with digits 0 to 9. If you add these digits, you will see 0, 1, 2, 3, 4 to 9 is 10 digits. That's why we say 12 in decimal is base 10. How do I represent this one? I put a 10. One second. I need my special glove on. So, okay. So I can write this one as 10. So this means 12 in base 10, which is your decimal values. Now in base 10, the digits which are allowed are 0 to 9. And you can see 1 and 2 are 2 digits between 0 and 9. Now, if I want to represent this one as exponent of the base is 10, I can write this one 2 times 10 exponent, the position of 2 is the first position. So 1 minus 1, which is 0, plus 1 times 10 exponent, 1 is the second position, right? So I can write it as 2 minus 1. It's always 1 minus the position number. So 10 exponent 0 is 1, so I get 2 plus 10 exponent 2 minus 1 is 1, which is 1. 10 exponent 1 is 10, so I get 10, so I get 12, which is exactly the same thing as 12 here. So I can represent any number in base 10 as the exponent of the base number. For instance, 78. I can write as 8 times 10 exponent 0, because this is the first position. So 1 minus 1 is 0, plus 7 times 10 exponent 2 minus 1, which is 1. 8 times 1, 10 exponent 0, any number exponent 0 is 1, so it's 8, plus 7 times 10 is going to give me 70. So the answer is 78, sorry, 78. Is it new to you or no? You already know about this one.
It's new.
Oh, it's new? I mean, this is how you express, any number to its base. give you another example because it's new to you. Let me erase this one. Or let me go and start a new one.
Wait, Mr. Shams,
Yes, sir.
if a number is in the in the first place, why do you even multiply it by 10? Why don't you just add it as like plus 8, for example?
Oh, the reason is that we are dealing with the base. The base is important because what you have already learned previously is that you think that every number is base 10. You've never heard, this is the first time you're hearing, that the base can change. For instance, in the computer system, can I have a number like this one be processed by the computer, 78, for instance? No, because digits 7 and 8 are not represented inside the computer. The computer works with on or off, 0 and 1. So this means that this 78, which is in decimal, I have to convert it to zeros and ones so the computer can understand. Is it clear or no?
Yeah, it is.
Okay, now
I'm getting there. Like, I'm getting the exponent part. Like,
Yeah.
what do we do with 0 and 1? Like, why do we have to write 0 and 1 on the multiplication?
because that's the digit which is in that location. For instance, 78, I know this one is going to be 10 exponent 0. This one is going to be 10 exponent 1. Agreed?
Yes.
Now, the question is that how many 10 exponent 0 I have? I have 8 of them.
Oh, okay.
Okay, and how many 10 exponent 1 you have? 7. So
Yeah.
you see 8 times 10 exponent 0 plus 7 times 10 exponent 1, which becomes 8 plus 70, which is 78, which is exactly this number.
That makes sense. Okay.
Okay, beautiful. Now, if I tell you, answer this question. 101, is it a valid decimal number, meaning a base 10? Is it valid? 101, is it valid? Any answer?
I don't think so because it would be 10 exponent 3.
No.
No, I'm asking, if I give you a number 101, 101, is it a valid number in decimal? Or
No.
it is not?
Yes.
It is, because in base 10 or decimal, what are the valid digits? Can somebody tell me? In decimal.
8 to 9.
0 to 9, right?
Yeah, 0 to 9.
0 to 9. And this number 101 is composed of 1 and 0, right?
Yes.
So it's a valid decimal number if I put a 10 here. So this is okay. Agreed?
Yes.
If I tell you 101, is it valid in base 2 or binary? I'm going to write it like this, base 2. Is it valid in base 2? What are the valid digits in base 2, binary? What are the valid digits in binary? You already know it.
1 and 0.
1 and 0. Is any digit here is other than 1 and 0?
No.
No. So it's a valid
Okay.
binary number, right?
Yes.
Okay, so now, knowing this one, if I tell you number 101, what is your first question?
Is it a binary number that you can straight?
Exactly. What base are you talking about? Are you talking about base 10? Or are you talking about base 2? Or let's make it different. Are you talking about base 3? Can I have 101 in base 3?
Yes.
Why? Why?
Because there's the
Because what are the digits in base 3?
1.
No. The digits in base 3 are 0, 1, and 2. That's it. And in this number, do you have any digit other than 0, 1, 2?
No.
No. So this can be also in base 3, right?
Yes.
Exactly. This means that you have to be clear from now on. It is not pure math in decimal. Now we are talking about number representation. If I give you 101, you have to tell me, sir, what base are you talking about? Is it base 2 or 3 or 4 or 5 or 6 or 10 or 11, 12, whatever you want? So to make life easy, we always, when we represent a number, we always show or display the base 2. For instance, I write 101 base 10. This means 101.
Wait, Mr. Shams,
Yes, sir.
can you just please explain the base again, like what it means again?
Okay, base means this number. This 10 means that in this base, only digits 0, 1, 2 to 9 are acceptable. To 9, remember, 0 to 9 is 10 digits.
Mm-hmm.
Okay? So when I say 101, 3 here, this means that there are digits 0, 1, and 2. That's it. And 101 is valid in base 3.
So in
But-
base 3, sorry.
Yeah.
Can I just clear something up? So
Yeah.
that means in a number in base 3 could only be 0, 1s, or 2s?
Exactly. So this means that a number like this one is valid in base 3.
Oh, because it has 2 zeros and 2s.
Exactly. It has the digits which are valid in that base. But this number, if I tell you, 202, is it a valid number in binary or base 2?
No.
Exactly. Why not?
It's because in binary, there's only zeros and ones.
Exactly. You got the idea. Okay. So now to make life easy, I am not going to talk about base 3, 4, 5, 9, whatever. I'm going to talk only about base 10 and 2. That's it. But remember, in computers, it's not just base 2 that you're going to talk about. We are going to just mention base 16 too. Okay, so let's start, talking about conversion. Okay, let me just start the new one. It's faster. Okay, so let's say I have a number like 15, and I say a 10 at the bottom. This means 15 in base 10. And if I tell you to represent it in the powers of the base, you are going to write this one as 5 times 10 exponent 0. Remember, this 5 is in the first placeholder, so 1 minus 1 is 0, plus 1 times 10 exponent. This is the second placeholder, so 2 minus 1, which means 10 exponent 0 is 1, so 5 times 1 plus 1 times 10 exponent 1 is 10, so I get 15. Okay? Which is the same number, right? Agree? Everybody understood?
Yes.
Okay, now I'm going to do the same thing, but with binary. I'm going to say this one. Is it a valid number in binary?
Yes.
Why?
Because it has zeros and ones in binary. Zero.
Exactly. Now, if I tell you to represent this one into the power of its base, you do exactly the same thing. You say the first digit, 1, times 2 exponent what number you think? Because remember, 2 is the base, so it's going to replace all these 10s. So 2 exponent what number? 0. Excellent. Plus. The next one is 0. So I say 0 times 2 exponent 1 plus 1 times 2 exponent 2. Agree?
Mm-hmm.
Now, 2 exponent 0 is 1. 1 times 1 is 1 plus 0 times any number is 0, plus 1 times 2 exponent 2 is 4, so 1 times 4 is 4. What is 1 plus 0 plus 4 is 5. So this means 101 in base 2 is the same as 5 in base 10. Everybody understood?
Yep.
Yes.
Exactly. Now, you may say, oh, it's very hard to remember 2 exponent 0, 2 exponent 1, 2 exponent 2. Let's write those numbers down. Remember, the first placeholder is 2 exponent 0. The second placeholder is 2 exponent 1, then 2 exponent 2, 2 exponent 3, and so forth. What is 2 exponent 0?
The first place?
What is 2 exponent 0?
0.
What is,
0.
oh, no, guys. Any number exponent 0 is what?
1, 1.
1. Excellent. It's 1. What is 2 exponent 2? I mean 2 exponent 1. Sorry, 2 exponent 1. What is this?
2.
2.
2. 2 exponent 1 is 2. Any number exponent 1 is the same number. What is 2 exponent 2?
4.
4.
Do you see the pattern here?
Yes.
Yeah.
You
Double.
multiply by 2. So the next one is 8. What is the
8.
next one?
16.
16.
16. What is the next one?
32.
32.
What is the next one?
64.
Next one.
128.
128.
What is the next one?
256.
256.
Exactly. What is the next one?
512.
1016. Wait.
512.
512.
So you just remember these numbers. 1 multiplied by 2, 2, 2 multiplied by 2, 4, 4 multiplied by 2, 8, 8 multiplied by 2, 16, and so forth. So when I get a number like 101 here, I'm just going to do it like this. 1 times 1 plus 0 times 2 plus 1 times 4. And you're going to end up with 5 again. Instead of using, these 2 exponent 0, 2 exponent 1. This is exactly with base 10. Remember, 10 exponent 0 is what?
1.
What is 10 exponent 1?
10.
What is 10 exponent 2?
100.
100.
Look at the pattern. You
100.
just multiply. Yeah, you multiply by 10. 1,000, 10,000, and so forth. So you do exactly the same thing. I mean, you say for 15, 5 times 1 plus 1 times 10 gives you 15. Everybody okay?
Yes.
Excellent. So
Okay,
let's-
there's some,
yeah,
there's
go
some
ahead.
people. There's some people in the chat that don't really. They're like commenting in the chat.
Oh, see, that's why I don't. Okay, let me go down. Okay, let's review this practice again because, okay, we have people that still they don't understand. Okay, the first thing that we are talking about is how to convert a binary numbers to a decimal number. For instance, if I give you 1, 1, 1, 0 in base 2, the question is that how are you going to change this one to a number in base 10, meaning a decimal number that you are using every day in life? Okay? To do that one, we said that always remember these sequence of numbers. 1, 2, 4, 8, 16. Every time you multiply by 2 here.
Sir,
Yes.
are you showing your screen?
Oh, I'm sorry. I'm sorry. Okay?
There you go.
Is it okay now?
Yeah.
Okay. So 110 in base 2, I want to find a number in base 10 here. Just remember this sequence of numbers. 1, 2, 4, 8, 16. What is the next one? 32.
Yeah.
Next one, 64. Next one, 128, and so forth. Now, what you do, the way you convert a number in binary to a decimal number is that you take the first digit, which is 0, multiply by the first number. So you get 0 times 1 plus. You get the second number here, multiply by the second one here. So you say 1 times 2. Then you get the next one, 1. And then you multiply it by the third digit here, which is 4. Now you just add them up. This one gives me 0. This one gives me 2. This one gives me 4. So the answer is 6 in base 10. So 110 in base 2 is the same as 6 in base 10. Are we clear about this process?
Yes.
Yeah.
Anybody else? Please write it in the chat if you don't have a microphone. Okay, so apparently there is nothing on the chat right now. Let me try another one. Let's say I ask one of the students and I say how old he or she is, and this was their response. The person said, I am 11010 in base 2 years old. How old is that person in decimal? Because remember, 11 or 10 is very hard to understand in base 2. This is a new environment, a new world for you. Change it to decimal and tell me how old is that person. Go ahead. Just remember the numbers are 1, 2, 4, 8, 16, 32, 64, and so forth. These are the numbers that you work with. How old is that student?
Can I answer?
Sure, go ahead.
26?
You said this is 26 in base.
Yeah.
Does everybody agree?
Yes, it's 26.
It's 26 years old. Okay, let's see how they got it. Again, we start always from right to left. I get the first digit 0. I multiply 0 by the number 1. So I get 0 times 1 plus the next digit is 1. So 1 times 2 plus the next one is 0. So 0 times 4 plus 1 is the next one. So 1 times 8. And the last one is 1. So it's 1 times 16. Now I'm going to simplify. This gives me 0. This gives me 0. 1 times 2 is 2 plus 8 plus 16. 16 plus 8 is 24. 26. Excellent job. So if somebody tells me that he or she is 110100 in base 2 is the same as 26 years old in base 10 in decimal. Are we clear?
Yes.
A little bit about excellent. This is conversion from binary to decimal. Let's do one more before I go to the next one. I just want to make sure everybody understands. I go to the store and I want to buy a video camera. And I ask the person apparently the only thing he understands is binary numbers. So I ask him, how much is the video machine that they have over there? And the guy tells me the machine is is this much in binary, which is 1,101,111 binary dollars. How much money is it in decimal? Again, whenever you have this in your test or problem, just write those numbers: 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. I think that's enough. 2, 4, 6, 8, 10, 24, 6. Yeah.
So I got 111.
How much?
111.
111. Okay, perfect. So that's one answer. Let's see, you know, if anybody gets another one.
I also got 111.
Excellent. Okay, let's see how we get this one. Again, we start from right to left. The first digit is 1, so I multiply 1 by 1 here, plus the next digit is 1 again, so 1 times this one, which is 2, plus the next one is 1, so I multiply 1 by 4. 2 times 2 is 4, plus the next one again is 1, so 1 times 8, plus 0 times 16, 0 here, and then the next one is 32, so it's 1 times 32, and the next one is 1 times 64. Now I'm going to simplify. 0 times 16 is 0, so 1 times 1 is 1, plus 2, plus 4, plus 8, plus 32, plus 64. Now I'm going to add it. 32 plus 64 is going to give me 96. 96 and 8 is 104. 104 is 108, 110, 111. Excellent answer. So you see how easy it is to convert from binary to decimal. Any questions here? Please, if you don't have a microphone, type it. I assume that everybody is clear about the operation. Now, the question is that how I go this way now. If I have a decimal value, how do I change it to a binary value? Right now, we worked from binary to decimal. Now, let's talk about decimal to binary. Very simple. So I'm going to start a new one. Let's say I have the number 10 in decimal. That's why I show it with the base 10. How do I change it to binary? The way I learned it when I was going to high school may not look easy to you, but it was easy to me to understand. If you do it another way, go ahead, as long as you get the right answer. And mathematically, your process makes sense. So how this is done, I do it, is very simple. Because my base is 2, I'm going to start dividing 10 by 2 until I get to a number which is less than 2. Let me give you an example. I divide 10 by 2. What do I get? The integer part. I'm not talking about 5. What is the remainder now?
5?
Nothing.
No, remainder. What if I divide 10 by 2, he said 5. Okay? What is 5 times 2?
10.
10. So what is the remainder now? 0. 0. So the remainder is 0, right? I put a circle around it and I write it under 10. Okay?
Okay.
Now I'm going to divide 5 by 2. What do I get? The integer part. Don't give me 2.5. No, don't give me 2.5. What is 5 divided by 2? 2, right? You get 2. 5 divided by 2, you get 2. What is the remainder now?
0.5.
No. The remainder
One.
is 1.
One.
Uh-huh.
Because 2 times 2 gives you 4, so the remainder is 1. Agreed?
Okay. Yeah.
Now, what is 2 divided by 2?
1.
1. What is the remainder?
0.
0. Excellent. Now, you get to a number which is less than the base, which is less than 2. 1. You stop, and you circle it. Okay? This is your last remainder. Now you go from bottom up. The first digit is 1. The second digit is here, 0. The next one is here, 1. The next one is 0 here. So this means 10 base 10 is 1010 in base 2. Looks a little bit strange to you, but it works. Any question about this? I'm going to do examples, don't worry.
Mr. Chams,
Yes, sir.
your chat is all the way up. You might want to scroll it down.
My chat is all the way. Oh, I'm sorry. Thank you. Very good. Okay, that's okay. These are such confusing times. I understand, SW. Just be patient. That's all I can say. You need practice. And that's why the easier than you think is the best site to do practice. Just wait. You're going to do a lot of practice. In 10 minutes, you're going to be a pro in converting from binary to decimal, decimal to binary. So just be patient. Oh, the only thing you don't understand is the base. The base. Okay, the base tells you that how many digits are available that you can combine to come up with different numbers. For instance, in base 10, which is decimal, is what you learn every day. Previously, you only have digits 0 to 9. So I can come up with billions and billions of numbers by combining these zeros and ones. I can, combine it like 178, 3201 with all these digits. Now, life is not always base 10. The computer doesn't work with base 10. It works with base 2. So the only digits which is available in the computer is 0, 1, on or off. Now, you have to combine these zeros and 1 and come up with different numbers. For instance, I can come up with a number like this, or a number like this. That's all we are doing. And we are coming up with methods to convert from one to another one. That's all. So in this part, we are learning how to convert from decimal to binary. So let's do one more example, just to make sure everybody is okay. Okay, let's go with SW. SW, can you type your age, please? How old are you? I don't know who SW is. Apparently, it goes by the last name and the first name. SW, how old are you? 15. Okay, so SW is 15 years old in base 10, in decimal. Let's see how old he is in binary. Again, to do that, I'm going to start dividing 15 by 2. What is 15 divided by 2? The integer part.
So we just every time divide it by 2?
Every time. It's like decimal. Decimal, I'm going to show you, is the same because base is 10, you divide it by 10. But in binary, because base is 2, you divide it by 2. What is 15 divided by 2? The integer part. 7.
7.
What is the remainder?
5.
1.
1.
Yeah. 7 divided by 2. What is the division?
3. No.
Yeah, 3.
Yeah,
What is the...
1.
Oh, what did you... One second. What did you divide to get 7? I divide 15 by 2, I get 7, right? And then the remainder is 1. Then I divide 7 by 2, I get 3, and the remainder is 1. Then I divide 3 by 2, I get what?
1.
1.
1. The remainder?
1.
1.
1. Now, since 1 is less than 2, we stop. Then I go from bottom up, and I say SW, what was it? SW is 15 years old in decimal or base 10, which is the same as 1111 in base 2. Are you okay? Oops, sorry. Okay, now let's do one more example. And this time you tell me what the answer is. Tell me, what is the binary representation of 385 in base 10? Go ahead. Tell me, what is the binary representation?
I have the answer.
Go ahead. What is, just read the digits for me.
Okay, 100000011.
How many zeros?
Oh wait, wait. 1, 2, 3, 4, 5, 6, 7. 7.
7 and then 1, 1?
Yeah.
You got this? I have SW said 11, 2, 4, 6 zeros and 1. So it's going to be different from yours.
Wouldn't the one that is remainder at the end go back all the way to the first position?
I mean, you always go from bottom up. I don't know. You never go from top to bottom up.
So wouldn't it be 1170?
Okay, so yeah, it has to go from bottom up. I don't know the answer. I have to do it, with you. Okay, let's see how we do it. Again, we say 385 divided by 2 gives me 192. And what is the remainder? 1. 192 divided by 2 gives you, I'm doing it right here, 96. Remainder is 0. 96 divided by 2 is 48. Remainder 0. 48 divided by 2 is 24. Remainder is 0. 24 divided by 2 is 12. Remainder 0. 12 divided by 2 is 6. Remainder 0. 6 divided by 2 is 3. Remainder 0. 0 divided by 2 is 1. Remainder is 1, and since 1 is less than 2, we stop. So the answer is bottom up. So the answer is 1, 1, 0, 0, 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, and 1. So this answer that you got, you made a mistake. You are going from bottom down. No, this is not the way. You go from bottom up. You
Okay,
never go from the, yeah, that's the thing. So this means 385 in base 10 is the same as 11 6 zeros 1. Everybody clear?
Yes.
And I think people, they seem to be, they are much better with this one. I mean, I don't see any questions here. Now, before I tell you, what you have to do, let's do attendance. So whenever I say, your name, please use your microphone and say present or type in the chat, okay, when I call your name. Muhammad. Muhammad
Here.
Ali. Muhammad Ali.
Here.
Okay. Aisanur. Afsi. Aisanur. No. Okay. Vizwa.
Here.
Aryan.
here.
No, I didn't call Aslan. No. Don't worry. Ashton. Ashton. No. Amjad. Amjad. No. Arshdeep. Okay, Arshdeep here. Okay. Okay, SK, I haven't called your name. Please don't say present when I haven't called your name yet. Arshdeep. Arshdeep here. Gunjan.
Here.
Balram.
Here.
Ivan. No. Ivan Hines. No. Lakshman.
Here.
Chirat. No. Sukhraj. Kirat, you're here. Please. I called your name twice. Please. Sukhraj is here. Sarah. Mustafa.
Yeah.
Siddharth. Arshlir.
Here.
Namra. Gurtesh. Gursimran. Jasmine.
Here.
Jayman.
Here.
Theosopan.
Here.
Aslan.
Here.
Avi. Avi here. Zoha. Thank you. Chandni
Here.
and Sean. Okay, so again, Eisenhower FC, no. Ashton Baron, no. Amjad Boot, okay. Please listen and tell me present or text me. Thank you. And Ivan Hines, no, absent. Okay, so we are done with the attendance. Before I send you to do the exercises on easier than you think, anything unclear to you, so I can explain it? Okay, so everything seems to be okay. Look at this one. Let me stop. Do you see this screen on easier than you think?
Yes.
Excellent. Now, what I want you to do is, this is a fake student. You go to again. What period are you? Period 1 or 2? I mean,
2.
okay, let's say period 2, because it's confusing. I'm going to fix it. Now you go to binary system now. No more computer hardware. Binary system. Then you go homework. Then available practice is this binary number. Now let's do example here. Go ahead and do this one. Convert to decimal. 100,000. Tell me, what do you get? Go ahead and do it on the piece of paper.
Sir, do we press homework?
No. I want you to do this one first of all. The one that you see on the screen. Do you see it right now?
Oh, yeah.
Yeah. So convert 100,000 to decimal. What do you get?
32.
You got 32? Let's see. This is 1, this is 2, this is 4, this is 8, this is 16, 32. Excellent. Now, if I click on check answer, you can see that 32 here. That's it. This is what you have to do. You have to convert from binary to decimal, decimal to binary. I have already set it for 20 minutes. So go ahead and start doing this practice. Everybody clear?
Wait, when we go on the select course unit thing, do we press worksheet or homework?
No, homework. You never play with worksheet, just homework.
Okay, thank you.
Yeah, okay. And do you see the homework when you select it?
Yeah.
Start doing practice, please.